My name is Ankur Srivastava. I am going to present a topic on instruction types and formats. It is a part of computer organization and architecture. It is taught in CSE department, CSE AI department, as well as in some other courses. Instruction types and formats is a part of computer organization and architecture. It is studied in Unit 3rd. We will see the topics that should be covered today are introduction to instruction, what are instruction types, what are instruction formats, significance of instruction in computer organization. Now, what is instruction? Instruction means some set of points given to the computers, as well as some set of steps through which we can conduct a program over here. Here we have given a definition, that is a computer instruction refers to a binary code. Binary code means we are going to represent that instruction into only two formats, that is 0 and 1. Binary code that controls how a computer performs micro operations. Now, what is micro operation? Micro operations are some small operations which are done to conduct an instruction. So, to continuing my presentation, how a computer performs micro operation in a series, they together with the information. Now here information means some set of rules or some set of regulations over here. Some raw data is also are saved in the memory. Every computer has its own set of instructions. Operation codes and opcodes and addresses are the two elements that they are divided into. Now, what are operation codes as well as opcodes? Operation codes, let's suppose we take an instruction to add two numbers. So if we are going to add two numbers, let's suppose C is equal to A plus B. What is operation code over here? Operation code is add, that is C is equal to A plus B. Now, what are operands? A and B are the operands. Now, these instructions need to be executed using such types of instructions which are given in the slide. Now, in the types of instructions, we are having four types of address instructions. Now, number one is 3 address instruction, 2 address instruction, first address instruction, or the 0 address instruction. 0 address instruction is also known as stack-based address. Now, if we are going to see that what is 3 address instruction, so a 3 address instruction has the following format: source 1 operation, source 2 operation, source 3 operation, and destination. Now, what does these items mean here? Source 1 operation, source 2 operation. Now, source 1 operation means, now let's suppose we take an example. We have to add 3 numbers. D is equal to X plus Y plus Z. Listen once again. Add. We have to add in the 3 address instruction, and we are given that we have to use source 1, source 2, source 3, and destination. Now, destination means where we are going to add that X plus Y plus Z. So, add is the operation over here, and the X, Y, Z are the operands. We have to calculate the value of X, Y, Z, and it is an instruction given to the computer. In the next slide, we will see that what is 3 address instruction. The previous was the 4 address. Now this is the 3 address. A 3 address instruction has the following general format: source 1 operation, source 2 operation, source 3 operation, and destination. So in the 3 address, we are having add X, Y, Z. Okay. So it is the same definition as the previous one. In the 3 address, we have to use 3 registers over there. Source 1 is the 1 register, source 2 is the 2nd register, source 3 is the next register. Now, next one is the 2 address register. Now, similar, when we are using in the 3 address instruction, we are using 4 registers over there, or we can say that we can use 3 registers, and we can add the all these 3 registers, and we can copy that value to the main register, that is the destination register. Now, in the 2 address instruction, a 2 address instruction has the following general format: In it, we are having source and destination through which we can do our operation. Now, operation is add X and Y. So we are we are having only two source operations. Source one is the X and source Y is the source two operation is the Y. So in the similar way as we are using in the three address instruction, we can also do the two address instruction, but the difference is that we can use only two source registers over here, and in the three address instruction we were using three registers. Now next one is the one address instruction. Now as compared to three address, two address, and in the one address, as it names one address instruction, we have to use only one address. One address instruction has the following general format: operation source, which includes X. So we have only one address instruction. So as compared to other instructions, now we will move to zero address instruction. In the zero address instruction, the positions of the operands are implicitly represented. The instructions use a structure called a push down stack to hold operands. As I told earlier that zero address instruction follow the rule of stack. Stack is a data structure part and which is used using two operations, that is push and pop operation. When we are going to push in the stack operation, then we have to insert the item, and in the pop operation, we just delete the instruction, or we can say item. In the next slide, I have given the some other definition for the instruction formats. Now, what are instruction formats? As already we have seen that we are having four types of instruction format. Number one is, we can say that zero address also. Next one is the one address. Third one is the two address, and the last one is the three address. Now, another definition given for instruction formats: a collection of operation codes as well as operands that handle the operation codes are included in the instruction. The bit design in an instruction is supported by the instruction format. The operands, opcode, and addressing mode are among the fields. Now, what are operands? As I told before, let's suppose D is equal to X plus Y plus Z. So here operands are X, Y, and Z. Now, what is opcode? Opcode is the addition operator which we have used between X and Y as well as Y and Z. Now, what are addressing mode? We are having various type of addressing modes in our computer organization and architecture. Addressing modes includes like stack addressing modes, implicit addressing modes, okay, index addressing mode. So when we are doing operands with using opcode, then some addressing modes are also required. Okay. Now we can see the further definitions. In most cases, the instruction length is kept in multiples of the length of the character, which is 8 bits. Several bits are assigned to the operands, opcode, and addressing modes whenever the instruction length is fixed. Moving towards the next slide. In the next slide, we can see that what is interpretation. The following factors can be used to interpret the function of the allocating bits in the instruction. Now, when the instructions are given, some bits are allocated so that the operands and the operators can be executed in an easy way. Now, number one is the number of different addressing modes. As I have told that various type of addressing modes are used over here, like register addressing mode, indirect addressing mode, okay. Direct addressing modes are there. Count of operands. So how many operands you are using to conduct that instructions, which is given by the CPU. The total number of address lines, the total number of register sets, the total number of CPU registers. Let us take an example over here. Now, D is equal to X plus Y plus Z. So I have taken X plus Y plus Z. So the total number of register sets required are 3 for X, Y, and Z. Count of operands are X plus Y plus Z. 3 operands are there. That means count of operands are X, Y, and Z. The total number of address line, if we are taking 3 operands over here, 1 address lines is sufficient, or we can say some other address lines are also taken. Now moving towards the next slide, we are having some advantages of 0 address, 1 address, 2 address, and the 3 address instructions. Now let me see that what is the advantage of 0 address instruction. They are simple and can be executed quickly, since they do not require any operand fetching or addressing. They also take up less memory space. Now, why this is simple and can be executed quickly? Because it is holding only 0 address that works on the stack. Just we are going to insert the item, and just we are executing that item, and we are just deleting. That means it is reading the instruction from the lower level to the upper level. In the 0 address instruction, why this is simple? Because it is holding only 0 address instruction. That is why it is simple, as well as it can be executed quickly, because it is not holding so long of data. Now, next one is the 1 address instruction. They allow for a wide range of addressing modes, making them more flexible than 0 address instructions. They also require less memory space than 2 or 3 address instructions. Yeah, it is right that they also require less memory space than 2 or 3 address instruction. Why? Because 2 address holds the 2 source registers over there, and the 3 address instructions hold the 3 address instructions over there. That is why they are taking more memory in comparison to 1 address. So if we ask that which address instruction is holding the low memory, so it is, we can see that 0 address instruction is holding the low memory. Okay, that is why it is simple and can be executed quickly. So in the 1 address instruction, they allow for a wide range of addressing modes, making them more flexible than 0 address, because addressing modes are of different types, and in the 1 address we can take exactly 1 address. Okay, in the next slide we will see that what are the difference between 2 address and the 3 address. In the 2 address, they allow for more complex operations and can be more efficient than 1 address instructions, since they allow for 2 operands to be processed in a single instruction. Sorry. They also allow for a wide range of addressing modes. Now, if we are comparing 2 address with the 1 address, we can see that they allow for more complex operations and can be more efficient than 1 address. Why? Because 1 address is holding only 1 source register, and the 2 address instruction is holding 2 source address registers. That is why they are more complex, as well as they are more efficient. Now, they also allow for a wide range of addressing mode, because they are holding 2 address instructions. That is why they can handle more addressing modes over there. Now, what is 3 address instruction? They allow for even more complex operations and can be more efficient than 2 address. Why? Because they are holding 3 source address registers, source 1, source 2, and the source 3. Okay, so that is why they are more complex and can be more efficient in comparison to 2 address instruction, 1 address, as well as 0 address. They also allow for a wide range of addressing mode. It is similar. Now, what are the disadvantages when we are using 0 address, 1 address, 2 address, and the 3 address instructions in the CPU instructions? Now, first one is the 0 address instruction. They can be limited in their functionality and do not allow for much flexibility in terms of addressing modes or operand type. Why? Because they can hold only the stack operations, and they cannot allow for much flexibility in terms of addressing modes. Why? Because they are only the 0 address instruction, and that is why they are not holding the so much of addressing modes. That is why it holds only the stack addressing mode in the 0 address instruction. 0 address instruction follow the rules of stack addressing as well as stack data structure. Now, next one is 1 address instruction. They can be slower to execute since they require operand fetching and addressing. Now, what is this operand fetching? Operand fetching, let's suppose we are given C is equal to A or C is equal to A plus B. Now, what are operand? A and B are the operand. Now, this operand must be fetched. It is used with the help of instruction cycle. We are having 4 steps, or we can say 4 operations in the fetching of the instructions. That is fetch instruction. We can now decode or encode, we can say, or interpret the instruction. We can now execute instruction, and we can interrupt the instruction. If there is any interrupt, then that instruction is again executed. So they can be slower. They can be slower to execute since they require operand fetching and addressing. That is why they are slower in comparison to 0 address. Now, in the 2 address instruction, they require more memory space. Why? Because they are using 2 address instruction. They use 2 registers over there. That is why they require more memory space than 1 address instruction and can be slower to execute. Then they require operand fetching and addressing. And similarly, why they are slower? Because they require operand fetching. Now they require 2 operand fetching over there and addressing also. So for that 2 operands, 2 type of addressing modes may be used, or 1 addressing mode is used, or maybe some other addressing modes is used. That is why in comparison to 1, 2, and 3 address instruction, 0 address instruction is more flexible, or we can say in terms of addressing modes, but it is limited also. So now we will see the 3 address instruction. They require even more memory space than 2 address instruction and can be slower to execute since they require operand fetching and addressing. Now, as we have seen the 3 address instruction previously, they require 3 source registers. Source 1 address instruction, source 2, source 3, as well as 1 is the destination. So that is why it is slower, because they are executing more operand. They need to they need to check 3 operands over there. Now, in the next slide, we can see what are instruction pipeline in computer architecture. So in the instruction pipeline, pipelining processing can happen not only in the data stream, but also in the instruction stream. To perform tasks such as fetching, decoding, and execution of instruction, most digital computers with complicated instructions would require an instruction pipeline. So what is pipeline? Pipelining is used to send the instructions in a proper way. Pipelining is divided in several parts. Let's suppose there are many parts such as SIMD, SISD, MIMD, MISD. SISD, single instruction, single data stream. SIMD, single instruction and multiple data stream. Similarly, MISD, multiple instruction and single data stream. MIMD, multiple instruction and multiple data stream. So pipelining can be defined as well as by the Flink's classification also. Flink has classified that pipelining is used in the computer architecture and organization. So pipelining processing can happen not only in the data stream, but also in the instruction stream. So what are the instructions given? That instruction stream, just I have told 4 types of instructions, pipelining instructions. So what are the tasks that needs to be performed by the pipelining? That are the fetching. So I have told that fetching instruction is done. Then decoding. Why we are decoding? We are giving some code to that instruction so that it can be easily executed from one place to another place. And execution. Now execution is done after the decoding part. When these 3 types of instruction cycle is completed, that is fetching, decoding, and execution, the next and 4th is the interrupt cycle. Let's suppose the work has been completed, then the interrupt is also done. And if there is any interrupt that this instruction is not done, so might be that decoding part or the execution part is done once again. So most digital computers with complicated instructions would require an instruction pipeline. So every computer needs to be their instruction pipeline. The next slide, we will continue that what is pipelining processing. In general, each and every instruction must be processed by the computer in the following order. So there is given some order so that we can execute our instruction. Number 1 is instruction, fetching the instruction from memory. Now we are having several types of memory over here. Let's suppose we are having secondary memory, we are having primary memory. So our data is mapped from secondary memory to the main memory, that is primary memory. In the RAM, we are having the instructions. So fetching the instruction from memory, it needs to take the instruction from the memory. Now instructions may be mapped from memory. Now second one is the decoding the obtained instruction. Now what is the instruction? Let's suppose the instruction is given that C is equal to A plus B. It is an instruction using two operands as well as one operator is also there. The second one is the decoding. Now when decoding is done, that means somehow it is encoded also. So in the after the decoding is done, that instruction was obtained. Then the third is the calculating the effective address. Now effective address is calculated. Effective address is that address in which that instruction is fetched as well as it is decoded. Fourth is the fetching the operands from the given memory. Now in the first part you have just fetched the instruction. No operands are there. You have just got the instruction that we have to add two numbers. In the fourth part, it is fetching the operands from given memory. So fetching the operands. Now, what are the instructions given previously was C is equal to A plus B. The instruction was to add two operands. Now, what are the operands? A and B are the operands. This is also taken from the memory. Given memory, that means it is provided that these operands are here. Now, fifth one is the execution of the instruction. So execution of the instruction is done, and if the execution is done completely, then interrupt is also taken over there, and if the instruction is not completed, again the interrupt is there. Now last part is the storing the result in a proper place. So storing means we are we are copying the data, we are copying the result from the that memory part to the executing part. Now we will see the next slide of basic instruction types. So in terms of reference, we are also having three types of memory types. Sorry, not memory types, basic instruction types in terms of the reference part. So number one is the memory reference instruction, number two is register reference instruction, and number three is the input output instruction. Again, I am repeating, in terms of reference, we are also having instruction types. We are having instruction formats, we are having instruction cycles, we are having instruction types in terms of reference. So that is why instruction is a very large topic. So in the memory reference instruction and in the register reference instruction and in the input output instruction, we have to see that what are the commands over here that can be given. Now we will see that in the next slide. First one is the memory reference instruction. The operands specified by memory reference instructions are AND, add, LDA, STA. Now from the number one AND, this instruction performs the AND logical operation between the accumulator's contents and the content that resides in the memory address specified by the instruction. The final result of the operation is stored in the accumulator. Accumulator, which is denoted by AC, is itself a register which is used by the processor over there. That means accumulator is a processor register. So this AND means we are using AND logical operation between the accumulator's content as well as the content that resides in the memory address. We can say that AND, that accumulator tends to accumulator plus memory over there. So the content of the accumulator and the memory is now transferred to the accumulator, main accumulator. Next one is add. This instruction adds the content stored in the accumulator with the content stored in the address mentioned in the instruction and stores the result in the accumulator. So AC is equal to AC plus, we can say, the register which is given over there. The result shall be stored in the accumulator. So this add is used. Now what we are studying, memory reference. That is why we are seeing that and is also using memory content, add is also using memory content. So that is memory reference instruction. Okay. Third one is the LDA, that is load accumulator. LD means load accumulator. Somehow it may be written over there. That is LOAD or LDA. LDA means load accumulator. If it is not given AC, then you can see that it is also a accumulator. Load accumulator, that means you have to load the value of accumulator. Might be it is from the memory. So this instruction stores the operand from a memory location in the accumulator. STA, see, now LDA was the load A, now STA is store A. Okay. ST means store. And you cannot change the command over here. STA means store. This instruction stores the accumulator's content in the address specified by the instruction. Now we will see the next one, that is register reference instruction. The different types of register operations are as follows. The symbol HLT, SZE or SZA. So what are the descriptions and what are the hexadecimal codes which are used for the register reference instruction? HLT means halt computer. Okay, HLT, it is written in capital letters, HLT. So HLT means halt computer, HALT computer, and hexadecimal code for halt computer is 7001. SZE, skip if E is 0, 7002 is the hexadecimal code. Skip if E is 0. So if E is 0, then you have to skip, not we have to, that the register skips that similarly. SZA, skip if accumulator is 0. SZE, skip if E is 0. SZA, that means accumulator is 0. Skip if accumulator is 0. Code is 7004. In the next slide, we can see the input-output instruction. So input-output instruction in comparison to register reference as well as with the memory reference, they were also using some commands. So in the input-output instruction, it is also using different types of input-output operations, which are as follows. Now, I have taken just some examples over here, 4 to 5. There are many input-output instructions. There are many reference in comparison to, in accordance to the memory reference as well as in the register reference. So I have taken just some of the examples over here, and there are many more instructions in terms of the input output as well as in the terms of register reference as well as in the terms of memory reference. In the case of input output instruction, symbol is IOF. Now symbol must be in capital IOF. Description, interrupt off, as previously I told in the address or in the instruction cycle. Now description for the IOF is interrupt off. Hexadecimal code is F0 and 40. That means F0 and 40. So IOF interrupt off. Okay. ION interrupt on. You can see the symbol and you may know that the what must be the description for that. Simple. IOF is the interrupt off. ION is the interrupt on. SKO. Okay. So skip on flag output. And the code for hexadecimal code for SKO is the F100. Okay. So skip on flag output. SKI, when O is given output, then here is I. So you can say that it is input. So skip on flag input. And its code is F200. Repeating once again the input output instruction. Symbol IOF means interrupt off. Code is F0 40. ION interrupt on F0 80. SKO skip on flag output. SKI skip on flag input. F100 and F200 are the codes respectively for the SK0, and the SKI. So I'm ending my session that what I have presented over here is the instructions which are used in the COA, computer organization and architecture. So what were the topics that I have taken? Introduction to instruction, as well as what are instruction types, what are instruction formats, significance of instruction in computer organization and architecture, disadvantages and advantages of the instruction formats. We have used instruction formats of 4 types: 0 address instruction, 1 address instruction, 2 address instruction, and 3 address instruction. We have also seen the instruction pipeline also here. We have also discussed the instruction cycle also. Okay, that instruction cycle is of 4 instruction cycle. Okay, thank you very much.